Hi and welcome. I'm trying to learn biochemistry, today lipids, and after we've done it, we're gonna do median plane training. And if you participate in the median plane training, then it's at your own risk. Yes, and that is part 2 of lipids. And now we try to make a little presentation about that, what we had. So lipids. A second important group of organic compounds is lipids, and lip means fat. Maybe we're gonna save it. Lip means just fat. Okay, lipids make up 18 to 25% of body mass in lean adults. Let's say a quarter. Lipids are around a quarter of the body mass, and fat means lipid. Lipid means fat. Okay. Like carbohydrates, lipids contain carbon, hydrogen, and oxygen. Maybe we're gonna say it if it leads to something. So lipids consist, same way as carbohydrates, out of carbon, hydrogen, and oxygen. Unlike carbohydrates, they do not have a 2-to-1 ratio of hydrogen to oxygen. The proportion of electronegative oxygen atoms in lipids is usually smaller than in carbohydrates. Okay, we don't have a ratio of 2 hydrogen to 1 oxygen, like carbohydrates. H2O, that is water, 2 hydrogen, 1 oxygen. The proportion of electronegative oxygen atoms in lipid is usually smaller, so they have 3-to-1 or 4-to-1 of hydrogen to oxygen. They have less oxygen. So there are fewer polar covalent bonds. As a result, most lipids are insoluble in polar solutions such as water. They are hydrophobic. Okay, what can we say to this? We don't understand it completely. But we could say that carbohydrates have a ratio of hydrogen to oxygen of 2-to-1, while lipids, where the ratio of hydrogen to oxygen is higher. There are less oxygen, so the ratio is more than just 2-to-1. Maybe say it like that. And that means that it does not so easily make polar covalent bonds. It is less ready to make polar covalent bonds, and is therefore mostly insoluble, most lipids are insoluble in water, or polar solvents in water. They are hydrophobic. Okay, non-polar solvents such as chloroform and ether, however, readily dissolve lipids. So in polar covalents, they don't solute so easily. For example, water. But in non-polar solvents, like chloroform or ether, they do. Maybe you're gonna have it. Because they are hydrophobic, the lipids, only the smallest lipids, some fatty acids, are dissolved in the watery blood. Maybe we add that, maybe because we don't understand it completely, that irritates people if we say that. No. Some smaller lipids, the fatty acids, are able to dissolve in watery blood. To become more soluble in blood plasma, other lipids form complexes with hydrophilic proteins. The resulting lipid and protein particles are lipoparticles. Okay, smaller lipids, was it? Smaller lipids, the fatty lipids. Maybe that is very important actually. Smaller lipids, the fatty lipids, are able to solute in water. The other ones are oftentimes, or do sometimes, or form a complex, or form a symbiosis of nicotine with proteins which are hydrophilic, and they are then called lipoproteins. With hydrophilic proteins. The diverse lipid family includes triglycerides, fats and oils, phospholipids, lipids that contain phosphorus, steroids, lipids that contain rings of carbon atoms, icosanoids, 20 carbon lipids, and a variety of other lipids including fatty acids, fat-soluble vitamins, A, D, E, and K, and lipoproteins. I was thinking about it. Do we make a singular second video about just some examples of type of lipids? That is good written together. We have here bile salts needed for absorption of dietary lipids, vitamin K required for synthesis of blood clotting proteins. In a way, I would like to state bioinformations we had just about it. And I think we should actually do it. Do we mention that this is a diverse family, including triglycerides, phospholipids? I don't think so. We're gonna call it lipids, and we could technically even retitle it if we don't include it. I like to state by these information we have, these are very good information, just the function of lipids, or whatever we call them later. Okay, lipids. Lipid means fat, just means fat, and a quarter of a human is out of lipids. And carbohydrates, which is another form of organic components. Just carbohydrates. If I say it, I could say another important group of organic compounds. So we have a ratio of hydrogen to oxygen is 2 to 1. In lipids, the ratio there's less oxygen, and so the ratio is higher, and that makes them harder. That makes them not so easy to bond with polar covalents. What is it called? Polar solutions. We have non-polar solvents. I'm not familiar with the word. Non-polar solvents and polar solvents, and they don't make polar covalent bonds. They don't make so easy polar covalent bonds. That means they are not soluble in polar solutions like water. Some smaller fatty acids are soluble in water, but in general lipids are hydrophobic because of the low amount of oxygen. They don't so easily form covalent bonds with polar solvents. But they can team up with proteins. Okay, let's mention that maybe actually. But the fatty acids, the fatty acids, they can dissolve in watery blood. I think that is important. And to become more soluble in blood plasma, some lipids make complexes or team up with hydrophilic proteins, and they were even called lipoproteins. I think these are all informations. I'm going to start with second camera and I try to set it up. Let's look for it and we go back to something. Now, what is it? Is this a polar or non-polar solvent? They can dissolve. We wanted to mention it. They can dissolve non-polar solvents such as chloroform and ether. Non-polar solvents such as chloroform and ether, however, readily dissolve lipids. They are dissolving lipids. I think that's the same area. Non-polar solvent or polar covalent bond. It's just polar solvent. Covalent. Lipids. Lipid means fat, and the normal human body has around a quarter of it in it. Now, carbohydrates have a ratio of hydrogen to oxygen of 2 to 1, but lipids have less oxygen, so the ratio is higher. There's less oxygen, so it makes them harder for them to make polar bonds with polar covalent bonds with solutions, with polar solutions like water. That means that because the lipids have a smaller amount of oxygen, they don't dissolve in water, for example, in polar bonds, in polar solutions. Now, there is some things, for example, chloroform, whatever, where they are dissolving in, and some smaller lipids like fatty acids are dissolving in watery blood. It happens from time to time, or it happens regularly, that some lipids are teaming up with proteins. The lipids are hydrophobic, they don't dissolve in water because they have such a low amount of oxygen, they can't form polar covalent bonds in polar solutions. In non-polar solutions like chloroform, whatever it can be, this doesn't really make sense. Lipids. Lipid means fat, and the normal human body has around a quarter of it in it. Now, carbohydrate has a ratio of hydrogen to oxygen of 2 to 1, but in lipid the amount of oxygen is smaller. That means that lipids are not so readily dissolving in polar solutions like water. They don't form so easily lipids, polar covalent bonds with polar solutions like water. There are some smaller lipids like fatty acids which can dissolve in watery blood. In some non-polar covalents like chloroform, whatever, their lipids can dissolve. That means lipids are hydrophobic because they have a smaller amount of oxygen, and that makes them less readily to make polar covalent bonds with polar solvents like water. They are hydrophilic proteins, and if the hydrophobic lipids team up with them, they are then lipoproteins, and they can dissolve in blood, plasma, and plasma. Easy. Lipoproteins. And that is according to Gerard Totoga and Sandra Gabowski, Principles of Anatomy and Physiology, book, page 45, but this is now medical advice. Oh, this is also right. I'm going to stop the camera. And that was the biochemistry part. If you were here for biochemistry, you can go directly to the next part, biochemistry. If you stay here, we have 2 minutes left, almost 3, for our medium plane training. And if you participate in the medium plane training, then it's at your risk. We're bringing one leg up, pull the leg up and point with the toes down. Now bring the toes up and down. And the other leg up, pull the leg up and point with the toes up and down. And to the next exercise. Go to the side. To the side, the toes are pointing forward and we're stretching the inner side of the leg. And over to the other side. And now, one leg up. Right angle with the leg, flex foot, even line hips taller with the back, and press from the top against the knee, have a little bend in the elbow. And directly on to the next exercise. Now press from the inside. And now press with the knee up and to the side. Up and to the side. And over the other leg. Leg up, same setup. And press from the top against the knee. And press from the side. And now press with the knee up and to the side. In the last exercise, a heavy swing go. One leg up, press from the outside, and out slowly. And closing. And with the other leg up, press from the outside, and out slowly. And close again. Legs wide apart, breathing out. And again out. Again in. Out. Breathe in, close the legs. And breathe again out. Now that was the medium plane training. I thank you very much and until next time.